Asteroids. It feels like every other day there's some new headline warning us about a giant rock from space making a close shave with Earth. It can seriously feel like we're living in a cosmic shooting gallery. But what's the real story behind all these alerts? Well, in this explainer, we're going to decode those headlines and really separate the science from the sensationalism. I mean, if you spend any time online, you've seen a headline just like this, right? It's dramatic, it's specific, and it totally grabs your attention. It's absolutely designed to make you click and maybe, just maybe, feel a little bit anxious. And then you see stories like this one, about asteroids that actually hit us with only a few hours' notice. Now, these are usually tiny and burn up completely harmlessly, but that phrase, imminent impactor, that doesn't sound harmless at all, does it? It paints this picture of a universe that's just full of these random, unpredictable dangers. And the constant drip, drip, drip of updates on the odds, with numbers that seem to be getting worse and worse, well, it can create this real sense of information overload. It's this exact cycle, the alarm, the uncertainty, the confusion, that we are going to cut through right now. So let's get into it. Where do all these close call stories actually come from? Because if you look closely, you start to see a very, very familiar pattern. Yeah, the headlines almost always follow the same script. They focus on two things: size and how close it gets. We get these relatable comparisons like house size or the size of a commercial jet, and then they pair that with distances that sound terrifyingly close, like just 72,000 miles. The constant repetition of this formula makes these incredible cosmic events feel like these routine, everyday threats. Okay, so to see how this whole process really unfolds behind the scenes, let's track a real-world example. We're going to follow the short, pretty dramatic life of asteroid 2024 YR4 and see how it went from a potential threat to just a scientific footnote. This is how it almost always plays out. First, there's an initial sighting. The data is limited, so it suggests a small, but not zero, chance of impact. Then, as more telescopes get a look and gather more data, the orbit gets refined. Now, for a little while, the odds might even seem to get worse, which we see right here, with the chance increasing to 1 in 38. But with even more observation, that window of uncertainty shrinks and shrinks until the threat can be ruled out completely. And there it is, the final step. That initial anxiety-inducing headline leads to a definitive conclusion of safety. The system works. Uncertainty is just a natural part of discovery. It's not a sign that the sky is about to fall. Okay, but this whole process, going from a 1 in 53 chance all the way down to 0, it brings up a huge question. How in the world are scientists calculating these probabilities in the first place? It's definitely not just a guess. A huge part of this whole process involves ruling out something called keyholes. Think of a keyhole as this tiny little gravitational gateway in space. If an asteroid passes through it, Earth's gravity can actually tug it onto a guaranteed collision course for some future flyby. So the job of these scientists is basically to prove that the asteroid is going to miss every single one. But here's the really cool part. This tracking, it's not a passive thing. We're not just sitting back and watching and hoping for the best. Nope. Humanity is actively developing strategies to defend our planet. The main theory is something called deflection. Basically, giving a potentially hazardous asteroid a tiny little nudge, years or even decades before it's a threat, just changing its orbit enough to miss Earth completely. And we've actually put this to the test. NASA's DART missions successfully slammed a spacecraft into an asteroid to change its path. But, and this is super interesting, it also taught us something new and complicated. The impact kicked up these massive boulders, which is a whole new factor we'll have to deal with in any future attempts. This quote just perfectly captures the whole philosophy of the thousands of asteroid detectives all around the world. Their job is to systematically scan the skies, cataloging every single near-Earth object they can find. The goal is to build a comprehensive map of our neighborhood so there are no surprises. But what if we just shifted our focus for a second? Because the story of asteroids isn't just about defense. Every single one of these objects is also a potential scientific treasure trove. So after all that talk of threats, it is worth taking a moment to counteract all those scary headlines with this one single powerful number. Based on everything we found so far, the number of large, city-killer asteroids with any significant chance of hitting Earth is 0. The sky is not falling. And this is what we find when we start looking at asteroids not as threats, but as these incredible opportunities for discovery. We've found asteroids that have the chemical building blocks of life. We're sending missions like Psyche to study the exposed metal core of an ancient protoplanet, which could tell us about Earth's own core. We're finding cosmic fossils from the dawn of the solar system. These things are literally time capsules. So the next time you see one of those breathless headlines, remember the process behind it all. Remember the science, the defense, and the discovery. And maybe just ask yourself this question. Our need to protect ourselves has driven us to scan the heavens with incredible detail. But in our search for danger, what unimaginable wonders and fundamental truths about our universe are we going to find completely by accident?